Okay, in this video, we are going to talk about annuities. Annuity is a kind of investment where you are making a regular contribution to build your money faster. It doesn't mean that you have to always annuities comes like annual investment, but it doesn't mean that you have to do always the investment in once in a year. You can do once in a month or fortnight, or it's up to you. But the term itself represents just the investment you are making regular contributions once in a month. And that's the way people usually plan. Okay, if after 5 years I'm going for a holiday and we need some sort of money of that savings, and you can make a regular contribution every year to make that much money at the end of the 5 years to go for holiday. And so different purpose people can save in a regular manner to come up with a big amount end of the period, like 5 years, 10 years, whatever your plan is. So let's have a look at an example, then you will understand it's better. uh, Anna's mother invests $500 for her each birthday up to and including her 18th birthday. The money earns 6% per annum. How much will Anna receive on her 18th birthday? So it means the mother of Anna, she's investing every Anna's birthday, she's investing $500 in the bank. And after 18th birthday, so when she's finishing it, so 18th birthday is including, then she is taking out the whole money after giving the final contribution, 18th birthday contribution. Then she's taking the whole money out. So how much money she will receive? So you might think, okay, $500 she's investing every year. So 18 times she's investing 500, so it's something like $9,000. But realistically, it's not. Definitely, it will gain some, right? Because the interest it earns 6% per annum. What we can do in this problem? How we know that exactly how much money Anna will receive at end of the 18th birthday? What we can do? We can track each contribution separately. Let's Anna is the we know that the contribution, like for example A. Okay, the A is the contribution she's making. P is the how much contribution. A is the actually the final value for one contribution. P is the like how much she's investing, right? So investment or present value, which is $500, and then 1 plus r to the power of n, and that r is the interest rate, n is our the period, how many periods she's investing. Okay, and in this case I can say our p will be, and that is the formula for compound interest, because they are gaining the money in a compounded rate. So p is $500, she is investing once in a year. And then r would be interest rate, which is 6% per annum, so which is 0.06, so it's a per annum, right? And then she is doing a regular contribution for n, and how many years she's doing. Okay, that's the n, right? We are not talking about n in this stage because we are just tracking each contribution separately. So if I made like first contribution, definitely the first contribution A1 that you are making when she's having a first birthday, and then how much that first contribution can earn. If you think carefully, the first contribution when you are making, your present value is 500, yes. Then 1 plus r is 0.06, we know already, 0.06. And then it's coming as a, this is very important to understand, when you are investing this money, it's already she finished 1 year. So the money that you are putting, that $500, it will earn interest another 17 year. What is the leftover year? Because she could not get the first year interest because you are depositing that $500 end of the year. So that's very tricky part, you have to understand. So in this case, the first contribution will gain interest for 17 years, and which if you just simplify, it's just like a 500 times 1.06. If you add that in middle part, it's a 1.06, and then power of 17. Now if I think about the what is our second contribution will be then. So exactly the same way, 500, and then power of like 1 plus 0.06 power of 17, but in next contribution we'll make 16 years interest. So I can just straight away write down 1.06 power of 16. Second one will gain 16 years of interest, right? Okay, let's go for A of whenever she's making her final contribution, which is when she having a 18th birthday. So that 18th birthday, if I go a third contribution, fourth contribution, I'm just tracking separately as I said. So 18th birthday, how much in interest it will gain? 500 times 1.06 power of 0. Why? Because when you are depositing the final $500 in the bank, and then next day you are just withdrawing, you are not keeping that money anymore, because you are just taking the whole amount and gift her to buy something like expensive, like a car or something, right? So what you can do, you can just depositing the money but not getting any not gaining anything extra. Okay, so that's what it is. Now, so it means that's the total. If it is coming like the 16, then 15 is going slowly going down. So if I just add the total money you are gaining over the 18 years, whatever, like after 18th birthday, so it's actually you are gaining a 1 plus a 2. You are adding everything, right? So it's like dot 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 dot. You can go add up to 18. Okay, and then if you substitute the values, I'm just substituting here, and you know that a1 is already, we know, is 500 times 1.0617, and the next one plus 500 or 1.066, next one like 500 times. So what you can do, you can just take 500 common if you want. So I can just, in the very first, I can take the common, and then I can say, okay, if I add the next one, it would be just 1.0616 plus dot 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 dot, like, then it's just 1.060, right? Now you can see it's a good, like, it's a series, and that series is obviously, it looks, even if you want to write down another one here, it is definitely 1.06 of what, power 1. So power 0 1 is going up like that, right? So it's obviously it's a series, and if you think this is the first term and it's a 1, right? So our first term, if I write down here, you know that when you are adding a series Sn, like I'm just putting in a side note, probably it's better to, so Sn equal to a of r to the power n minus 1 over r minus 1. So this is the sum of the series, because it's a geometric series, and in this case we know it's r equal to 1.06, so it's the ratio between the two terms, and in this case n will be the number of the terms, and you can see obviously the 18 would be the number of the terms, because the second term is a 1, so it's ended up 17. The first term is so it's 1 to 17, and that this is the another one, so 18 term total. And what else? And you have a is the initial term, and your initial term is 1.06, 1.06 power 0, and power, it is just give any number power 0 is a 1, right? So it means we can just use this formula to get that part done. So now if I say what is the total coming, it means a of, then you just apply the formula, but you have to understand that 500 is also times with that formula, right? So you just put 500 times, and instead of putting a, you know, a is 1, so we don't need to put anything here, and then r to the power 1 minus, and r means we know that 1.06 already I wrote down here, power of n, and n is 18, minus 1 over r minus 1. Okay, now if I simplify this part, like that power part and that all this part is just giving you 500 times of, if I use the calculator, it would be 30.906. Okay, and then if you multiply this part, it will give you $15,452. I'm just putting in the nearest dollar anyway. So $15,452 she will receive end of the 18th birthday. So even though if you think there is no interest, you are just depositing 18 times 5, so it's only $9,000, but you are gaining that much if you got the interest is 6% per annum. So in this kind of problems, we have to work individual contribution, because the money I am depositing second year, it is not gaining the interest for like 18 years or 17 years, because we are we already 2 years gone. So like first contribution, it is only gain the interest for 17 years, whatever the leftover, because 1 year is gone already. So that's how you have to do the care contribution separately, and then add that to get the total amount. Thanks for watching. If you'd like to see more up-to-date videos, please subscribe my channel.